Hello, and welcome to the Energy Breakout session for the 2012 Autodesk Media Summit. My name is Alan Saunders, and I'll be joined here today by three of my colleagues, Benjamin Wang, Lynda Sharkey, and Ian Matthew. Here's our agenda for today, which will take about 50 minutes total. I'm going to kick things off, and then Ben and Ian will discuss the oil and gas industry, and then Lynda and I will cover electric utilities. Let's start by talking about energy industry challenges. According to the World Economic Forum, the world needs to build as much urban capacity in the next 40 years as has been built out over the past 4,000 years. That urban capacity also represents tremendous growth in energy use and related production, supply, transmission, and distribution, and all in a more sustainable, intelligent way. So the question to explore today is how can we do that, and how can design technology contribute? Let's take a look at the macro trends driving the energy industry today. First off, there's economic change, represented by more resource demand, more cost volatility, and more environmental issues. Then we have shifting demographics and changes in the workforce and their expectations. The paradigm is rapidly shifting from a 35-year veteran grabbing a paper network map or plant drawing and heading out to the site in a truck to verify a part or status, to a digital native expecting to access that information in 3D on an iPad or a mobile device. We also have new assets and new models. For example, plant or network sensors that rely on intelligent connectivity models to deliver value to operations. We also see more multi-firm and multidisciplinary projects requiring model sharing to meet project budgets and timelines. And finally, this all contributes to a data explosion, more intelligent data points, and a proliferation of 3D and imagery data. For that, customers need more data storage, analysis capabilities, and computing power, which echoes the cloud themes that you've heard earlier today. Those are trends that cover a very complex set of domains across the industry, from energy supply and production to renewable resource generation to transmission and distribution, and down to end uses like transportation and buildings. Autodesk is unique in having customers and solutions across all of these energy industry domains. Today, we're going to focus on two of these, oil and gas and electric distribution, where combined we have hundreds of thousands of users who are designing tomorrow's energy infrastructure today. Now I'm going to turn it over to Ben to discuss oil and gas. Ben?
Thanks, Alan. That was a great introduction and a good overview of the macro trends shaping the energy industry. So Ian and I will be covering the supply side of the energy equation, and we're going to focus on the Plant Design Suite in the context of the oil and gas industry. So why are we focusing on oil and gas? Well, it represents about 60% of the world's energy supply. And at Autodesk, we believe we can deliver great value to the industry's design and engineering processes. So first of all, what is oil and gas? To the average end consumer, oil and gas means the gas that runs your car, it's the natural gas that you cook with, and it's the heating oil that warms your home. At Autodesk, we see the entire oil and gas supply chain, and so that includes upstream, midstream, and downstream. Upstream includes finding the natural resource and getting it out of the ground. Midstream includes the storage and transportation of the natural resource, and downstream includes the refining and processing, as well as bringing the natural resource to market in some consumable form. Our customers span the entire ecosystem, so that includes owner-operators, engineering service providers, as well as suppliers and contractors. The owner-operators drive large capital projects. The engineering firms manage the design and engineering of the projects, and suppliers typically fabricate piping and components and also provide equipment to the facilities. Shell is a good example of a owner-operator. Bechtel is probably a name you're familiar with. They're a large engineering firm, and GE is a large supplier to the industry. So Alan covered some of the large macro trends shaping the industry, and many of these trends are driving real business challenges for our customers. One big challenge is around fast-track projects, which requires multiple project tasks to be done in parallel. Another challenge is around specialized skills and resourcing. It's difficult to find people who are trained in the technology, and when they are able to find people, they tend to be located in all different parts of the world. So project teams are spread around the globe. And this leads to challenges around maintaining accuracy and efficiency of your projects. And lastly, businesses often face complex technology that's difficult to install and difficult to maintain, and often yields very low ROIs. So at Autodesk, we're helping many of our oil and gas customers address these challenges. And we're seeing many of our customers use our software throughout the life cycle of their projects, from planning and design to construction and operations of their facilities. And they're using our products throughout their multidisciplinary workflows. They're using AutoCAD P&ID for their P&ID work. They're using AutoCAD Plant 3D for their 3D modeling and piping. They're using Revit Structure and AutoCAD Structural Detailing for their structural design. They're using Autodesk Inventor for their equipment design. And finally, they're bringing it all together with Navisworks to do their design review and clash detection. With that in mind, we've brought together all these products together in a single suite, the Autodesk Plant Design Suite. And so today we're announcing the 2013 version of the new Autodesk Plant Design Suite. The 2013 version comes in 3 editions: Standard, Premium, and Ultimate. It's an intelligent 3D modeling and review solution for plant design from small to large-scale projects such as oil and gas facilities. 2013 offers workflow enhancements that help simplify coordination across project stakeholders. It brings together AutoCAD P&ID, AutoCAD Plant 3D, Inventor, Revit Structure, AutoCAD Structural Detailing, and Navisworks. And newly available to all Autodesk Suite customers is Autodesk 360. As you probably heard this morning, they're cloud services for computing, storage, and data sharing. And so at this point, I'm going to hand it over to Ian, and he's going to show you how customers across the oil and gas supply chain are using the suite to help meet the energy supply challenges of today.
Here's a model of the oil drilling rig that RDS just finished working on. Oil drilling rigs are movable and are transported to wherever they're needed, and the owner only sees revenue when the rig is actually drilling. So fast turnaround is imperative on these reactivation projects. As you can see, these rigs are crammed for space. Now you can see how complex the rig is as we review the model in Navisworks. The piping and structural complexity is enormous, and space is at a premium. By using the Plant Design Suite, engineers and designers could model and steelwork and the piping, and the project engineers could review progress in 3D. One important aspect of the project is clash detection. Piping spools need to be prefabricated and delivered so they fit first time. There's no time for rework. A new feature in Navisworks 2013 is the Clash Detective user interface. It's simpler. In this example, we're checking piping against steel, and here's a clash that needs to be resolved. The piping must avoid the beam. In the Clash Detective, the project engineer assigns this to be resolved. Here's a case which is not a real clash. This is a piping support, so we mark this clash to be ignored. In this pumping station example, we'll show you a new feature for AutoCAD Plant 3D 2013, one of being able to insert custom pipe fittings into a pipe. Normally designers use piping specs to select the correct type of components, but sometimes specialty valves are custom ordered and their dimensions differ from spec valves. Plant 3D 2013 has a new easy-to-use interface which allows the user to input these dimensions, select end fittings, and also the type of operator that will be used for the valve. Then when the valve is placed in the line, the mating flanges are automatically inserted along with the bolts and gaskets needed for the connection. This keeps the materials takeoff current as the model is created. Let's take a look at some of the workflows in Plant Design Suite. First, let's take a look at steelwork. AutoCAD Plant 3D fully supports preliminary steel modeling, and here we can see the designer selecting the steel sections he wants and placing the columns on the grid. Once the preliminary steel layout is done, the steel layout is sent to the structural engineers for the detailed design, in this case Revit Structure. It's used for plant modeling and steel analysis, and the preliminary model is brought directly into Revit. Revit Structure allows structural engineers to work in many different ways, such as standard 3D or an analytical or simpler model. structural analysis is performed using robot, and as an end result, secondary steel and bracing may be added. Further analysis can be done as necessary. Then going back into Revit structure in 3D, the bracing can be edited so that it's placed in a more practical arrangement, as we see here. Now the structural design is complete and the model is ready for fabrication. For this we use AutoCAD Structural Detailing, also part of the Plant Design Suite, for all of the connections to be designed and documented. Now we are in AutoCAD Structural Detailing. All the beam to column and other connections are designed using the simple to use dialog interfaces. Let's look at how a beam to column connection is detailed using these dialogs. The connections, once placed, can be viewed in 3D so that the interferences with bolts can be quickly identified and corrected. Okay, so now let's take a look at piping. The most man-hours are spent in piping design. We first start with placing equipment such as pumps. Plant 3D comes with a comprehensive library of standard parametric equipment items. Here we place a pump and then copy it to place the secondary pump. So now we're ready to connect up the pipes. Let's take a look at piping on the suction side of the pump. We first extract the line list from the piping and instrumentation diagram, otherwise known as P&ID, and by selecting the line we automatically set the pipe parameters such as size, spec and line number. The flange is automatically placed and we can replace the concentric reducer with an eccentric reducer. And now we can show a new feature in Plant 3D 2013, the ability to place a connection on the flat side of a reducer. Now we'll continue to pipe up the drain by adding a nipple, a drain valve and then a cap. And while we're here, another new feature is to be able to replace the valve operators by simply selecting them from a library. In this case we replace the standard hand wheel with a T-crank. So now let's continue piping. Again we use the P&ID list to select the valve, and the piping spec automatically selects a flanged valve and places the mating flanges. Now we continue to route the pipe up to an elevation of 7 feet 6 inches and then again in a horizontal direction. So now we take advantage of AutoCAD and simply copy the piping we placed over to the other pump and update the line number from the P&ID line list. Now all that is left is to connect the piping to the nozzle on the column. Plant 3D will perform automated pipe routing and we simply accept the suggested line route that is our preferred route. Now we connect the other pipe to the one we just routed and the connecting T is automatically placed. Finally, let's go ahead and place supports to hold up this piping. The interface has been made better in Plant 3D 2013 and we simply locate the supports. The size is determined automatically from the pipe and we can easily adjust the support length as we see here. Now let's take a look at the equipment workflow. The equipment supplier may use Autodesk Inventor to do the mechanical design of the equipment, and here we will take a look at how we can fully exploit this in the Plant Design Suite to improve the plant design. First, the Inventor model contains details that are not necessary in plant layout. An Inventor contains a function that allows us to suppress these details without loss of integrity to the Inventor model. Next, we remove the internals to give us a simpler representation. And finally, we make the piping connections intelligent so that we can intelligently connect piping to the equipment. This process is contained within the BIM exchange function in Inventor, and the result is an accurate representation of the equipment that takes up much less disk space so that we can place it in the Plant 3D model. Additional properties can be entered. And then, when we bring this into Plant 3D, it acts exactly the same way as if the equipment was parametric equipment placed in the Plant 3D model. The final part of this workflow is to place this equipment into the Plant 3D model. We rotate it in the same way as we did a pump. We assign a tag, and we can simply go ahead and make the connection from the pipe rack directly to this inventor equipment. The bill of materials is automatically updated as we complete this task.
Thanks, Ian. That was great. So what's the summary and what are the key takeaways? So Ian showed how 3 customers in the oil and gas industry are using Autodesk software to help meet the challenges of supplying energy to the world. Using the Plant Design Suite, customers are able to use AutoCAD Plant 3D, AutoCAD P&ID, Inventor, Revit Structure, AutoCAD Structural Detailing, and Navisworks together. And they're benefiting from enhanced customer workflows enabled by the Plant Design Suite to deliver projects on time, on budget, and with minimal errors. Thank you.
Thanks, Ben and Ian. Now we're going to shift gears and talk about electric utility distribution. There are 2 key things that we want to share with you today. First, there's the idea that smart grids start with smart design, and electric utilities are moving towards model-based design and intelligent modeling to manage the complexity of today's smart grids. Second, we're very excited that our 2013 release of the Infrastructure Design Suite is now available, and this suite now includes 2 key components of our model-based design offering for utilities: Autodesk Infrastructure Modeler and AutoCAD Utility Design, as well as streamlined workflows across the offerings already in the suite, including AutoCAD Map 3D, AutoCAD Civil 3D, Raster Design, and others. So why do we say smart grids start with smart design? When we look at what it takes to power up a building like the building we're in today, the lights, the air conditioning, the flat screens, we can sometimes forget about some of the design decisions that are made to deliver that power. You start with the building itself, and its orientation, its systems, and its architecture obviously impact energy use. But then you extend to the utility network, and there are design decisions regarding the size of transformers and conductors, and then the connection point to the network itself. Is it an underground or overhead network? Where are the facilities located, and what's their visual impact on the community? Even things like what's the optimal routing, the cost and environmental factors for the transmission lines. What's the best site for renewable resources, and what are the safety considerations? So there are a series of design decisions, and these are all raised to an even greater level with smart grid programs. So it's now even more important to understand how all the elements of the network relate and are connected. Intelligent models, shareable across stakeholders, become critical. Utilities have been evolving to intelligent modeling for a while. This has been an evolution from a drafting environment where the output of the engineering design process has been a CAD file or a paper map that someone takes out to the field. With our AutoCAD Utility Design product, we've introduced true model-based design for utilities, the ability to lay out and document with productivity tools and the utility standards built into the product, the ability to aggregate CAD and GIS data into a single cohesive model, and the ability to estimate project materials, equipment, and costs as you're going through the design process. Now with our utility design solutions in the Infrastructure Design Suite, we're able to offer a complete model-based design solution for electric distribution, covering the full plan, design, construct, and manage lifecycle. So that's the news for today, a full model-based design solution for electric utility distribution that meets today's smart grid requirements, and also introduces streamlined workflows and the framework for our Autodesk 360 solutions to accommodate the data explosion and the need for mobile solutions that utilities need. Now Lynda is going to demonstrate how the products in the Infrastructure Design Suite address some of the key utility challenges and workflows that we've discussed today. Lynda?
Let's have a look at what many utilities have to start with. It's a plain AutoCAD drawing. Don't get me wrong, it's very pretty and somebody obviously poured a lot of their soul into creating it, but it's still just lines and shapes on an electronic page. How can utilities take this information that lives on plain AutoCAD layers and start using this information to build an intelligent model? Well, as a starting point, they may want to include other data, such as aerial photography, to get a better picture of existing conditions. Data is often held in disparate formats, but dragging and dropping this into AutoCAD Map 3D enables utility customers to aggregate existing data into a familiar AutoCAD environment. Another challenge they may face is incomplete data sets. The only data for a certain area may be a scanned picture of a map. But the Infrastructure Design Suite 2013 contains tools which enable you to bring this data in, even if it isn't georeferenced. There are tools for processing images and tools for cleaning up images, and it's a simple matter of choosing the size of dots you want to eliminate, leaving the raster much clearer. Now what you can do is place the image in the correct geographic place by correlating points in the image to points in the existing condition. We'll choose one point over here and a point in the real world, and then do the same at the other side of the image. Once this is done, the image will be put into the correct geographic position and we're ready to create vector data. Vectorization tools enable utilities to create lines, rectangles and polylines from scanned paper maps in a fraction of the time that it would take to redraft them. Now, these AutoCAD lines are a great start, but more and more utilities want to use their design and as-built data in intelligent models. So you have the ability to classify this data into real-world object classes, complete with default attribute information defined according to your standards. We saw how tools in the Infrastructure Design Suite have made it possible for utilities such as SwissGrid to complete tasks in hours instead of days, assimilating data from over 20 different utilities into a single source of truth. Now let's have a look at how utilities can improve design productivity and address changing requirements. Let's imagine we're redeveloping a street, and part of the redevelopment is the undergrounding facilities and installation of electric vehicle charging stations. New to the Infrastructure Design Suite 2013 is AutoCAD Utility Design, which can help utilities design faster and smarter. Because it's built on AutoCAD Map 3D, the exact same geographic and CAD data can be used as base maps. Also, the newly created and classified CAD data we created in the previous step can be converted into an intelligent industry model. This particular utility has switches and transformers held in Esri shapefile format. These can be added to the conversion dialog along with the CAD lines and poles we created from the raster map. Each data layer will be matched to a layer in the model, and attribute data from the source will be mapped to attribute columns in the industry model, such as assembly unit being mapped to model name. The same process can be followed for other data sources, and this data mapping profile can be saved for further use. Now we can see the newly created data, and if we click on a feature such as this pole over here and take a look at its properties, we see the attribute data as well as the connectivity data, showing the various facilities that are connected to it. We could even connect on one of these little knuckles to disconnect facilities from each other. But before we start our underground design, I just wanted to point out some of the built-in design rules which make it easier to right-size facilities and streamline the design process. AutoCAD Utility Design has an auto-validation process which flags errors as you go. So we'll switch to 3D for better perspective, and I'll draw a simple 3-pole overhead line. Now, once this is drawn, we can see there's obviously errors, and if we validate the design, we can see all the design errors that need to be addressed. By clicking on each error, we're given suggested solutions. Then by clicking on these solutions, the error is resolved. As we click through all the errors, you can see the design on the right gradually taking shape, with wires being attached to poles, pole heights being updated, and guys and anchors being added until all the errors in this particular part of the design are resolved. However, new to the 2013 release is the ability to automatically resolve design errors according to rules you configure in the model, meaning that the same type of 3-click, 3-pole overhead line that I drew before will give you the exact same design results, except that the error resolution was done for you and no errors show up on the validation results dashboard on the left-hand side over here. So let's go back to our new street development and look at configuring a model to accommodate changing standards that modern utilities need to deal with. The industry models are configurable, and in this example we want to extend the service point category to include a curbside electric vehicle charging station. It's a pretty simple matter of adding a new row and giving the service point a name, default description, default settings. We'll give it a nominal voltage, structure type, and because these types of facilities may be built by the utility but owned by another company, we'll set the ownership type to private. You're also able to assign a style for the new facility so that when the facility is drawn, it will automatically use the EVCS file. Once configuration is complete, design work can start. We can start by digitizing a service point and selecting the new EVCS facility from the list. Zoom in and click to place a facility in exactly the same way you digitize an AutoCAD point. But if we zoom into one of these and click on one of our little features and check the properties, we can see that the facility we've just drawn has all the default properties we stipulated in the model configuration. Now we can continue with the underground design, creating vaults containing a transformer and using AutoCAD Utility Design's intelligent model topology to make sure that we have proper connectivity between facilities. So by drawing in a secondary line with a duct, we can actually snap to the transformer itself, making sure that we're not just drawing lines and points on a page, we're drawing an intelligent, topologically correct model. You've seen how utilities such as Anchorage Municipal Light and Power and SwissGrid have been able to use the power of configurable data models to accommodate changing standards and built-in design rules to help spot errors and address them intelligently. But what happens next? Facilities don't just go away once they're designed and energized. They need to be managed and maintained. I mentioned that AUD is built on AutoCAD Map3D 2013. This means we can open the same type of industry model drawings in MAP and use the intelligent industry data to analyze and maintain the network. There are tools for exploring connectivity, for example. By clicking on a transformer, it will tell me that there is one backwards connection from the primary line and 3 forward connections to houses. There are tools for analyzing the entire network or components of it, and the Workflow Explorer contains a number of regularly used tasks, such as what's feeding a device or running a network trace. If we decide to run a network trace, as we do here, we can just click on one of the tasks in the workflow provider and click Execute. So by choosing Start and End points for the trace, AutoCAD Map3D automatically tells us which network components are connected to the 2 segments. By integrating design data into the corporate GIS, utilities can help eliminate data entry backlogs and help minimize costs as well. And here's another reason to love the intelligent model. As well as being able to use data in AutoCAD Map3D and AutoCAD Utility Design, the exact same data that we're using can be used to build an infrastructure model. For example, utilities could connect to the AutoCAD drawing which contains their street redevelopment and filter the layers within it to select only the layer with the new street layouts. So immediately stakeholders can get a better visual understanding of what the development may entail. And since utilities are often targets for NIMBYism, the not in my backyard syndrome, they can also create a catalogue of their facilities so people can see what they look like. It's a simple matter of creating a new catalogue item and pointing to the 3D model of the facility. Then it's ready for use. Again, our utility can just connect to the DWG of the street development, except this time we'll filter out everything but the electric vehicle charging stations and bring them into the model. Then, once they're brought in, they're ready to be styled with our custom model of the EVCS. This is really powerful because a utility can use a single DWG containing design information or as-built data from the GIS to create an infrastructure model. Now utilities have the ability to give stakeholders an intuitive view of what the project will look like in the existing environment, and even be able to show what underground facilities will be installed as well. We've seen how the Infrastructure Design Suite 2013 can help electric utilities better manage their networks once they've been designed and built, and also how they can use the exact same data they own and manage to create a 3D infrastructure model which can help them better communicate design and project intent to stakeholders.
Thanks, Lynda. That's an excellent demonstration of some of the capabilities and utility workflows that are available in the Infrastructure Design Suite. So Lynda mentioned several examples of the value of model-based design for utilities, and I wanted to recap a couple of those here. First of all, utilities like Anchorage Municipal Light and Power use our AutoCAD utility design product to really be able to drive more efficiency in their design process and at the same time apply their standards, their utility design standards in that process. So they can complete design tasks in hours versus days. Secondly, utilities like SwissGrid are able to apply utility standards and regional requirements to drive consistency and compliance in their business. So using our Map 3D and the industry models in that product to really drive consistency and compliance. Finally, utilities like Duke Energy are using model-based design, in the case of Duke Energy, for their substation design to reduce the overall project time by leveraging the design information to improve both the design efficiency and stakeholder buy-in throughout the process. So those are just some quick examples of some of the value that utilities are driving by moving to model-based design and using the products that are in the Infrastructure Design Suite. So getting back to our original slide here, we see that intelligent modeling and model-based design are really two of the key capabilities that are going to enable us to build out the energy capacity we need over the next 40 years to serve the growing requirements. Thanks so much for joining us today. We appreciate your time and attention.